I thought the 20th century's most important event in Idaho was when Dick Buick shooshed down exhibition at Sun Valley in 1952 on wooden skis. But then John Thornton of NWFPA introduced us to Idaho National Lab just down the road. We learned that the lab was a test range for naval guns in World War II and later designed the first nuclear reactors for submarines and civilian power generation. It now does research for homeland security and energy efficiency. We're now going to hear 2 3-minute elevator pitches. First up, Aaron Wilson. Here he is receiving an award last year for Outstanding Project in the National Labs.
Hello, my name is Aaron Wilson. I'm a research chemist with Idaho National Laboratory. For the past 4 years, I've been developing a technology called switchable polarity solvent for osmosis, or SPSFO. SPSFO is being developed to treat challenging waste streams with high concentrations of dissolved solids, a segment of industrial waters for which there's no good solution at the moment. We hope to do this at a fraction of the cost of existing water treatment processes. At its core, forward osmosis involves the transfer of water across a semi-permeable membrane from a feed solution to a more concentrated draw solution. This process is spontaneous and requires no energy input. And because FO does not involve the hydraulic pressures used in reverse osmosis or RO, it also doesn't suffer from the same degree of fouling as RO. When FO does foul, it can be more easily cleaned than RO. In fact, FO is a valid pre-treatment for RO and is very likely to have application in the food processing industry that involves a lot of solutions with a high fouling propensity. As I mentioned, at the core of FO, there's no energy requirement. All the energy is put into the system in the draw solute recovery step. The recovery could be a conventional water treatment technology like distillation or RO, but using RO means the process is limited to concentrations that RO can treat, and the fraction water that can be obtained is also limited to what RO can obtain. Distillation has significant energy costs with the vaporization of water. This provides the opportunity, since given the FO draw solute is isolated in the FO system, we have the opportunity to select special draws that can be separated at a cost-effective manner different than what other water treatment systems can use. Our innovation was to use switchable polarity solvents as a draw solute, which separate depending on the presence of carbon dioxide. In their aprotic form, tertiary amines we use are oily, nonpolar liquids which are immiscible with water. However, when CO2 is exposed to water, it generates carbonic acid. That carbonic acid reacts with some of our tertiary amines to form highly concentrated acid-base pairs, much higher in concentration than can be reached with sodium chloride. This allows SPSFO to treat highly concentrated feed solutions and obtain very high water recoveries. Once they've obtained this water and have been diluted, the product water can be recovered from the draw solution with low-grade heat, which drives off the CO2 and causes a phase separation between the amine and the product water. Because the SPSFO process is thermally driven and heat is approximately 1/10 the cost of electricity, the SPSFO process should be significantly less expensive than electrically driven RO processes. To conclude, SPSFO is a technology that has the potential to treat high concentration feed solutions and recover the majority of the water in the feed stream at a cost that is less than existing water treatment methods. If you have any questions, I look forward to hearing them.
Next up is Greg Muller. He also wins awards for research and for his innovative teaching methods.
I'm Greg Muller, a professor from the University of Idaho, and today I'm going to brief you about a forward-looking water treatment process called NUTEC that operates at the nutrient energy water nexus. The potential of NUTEC as a next-generation water treatment is best illustrated using a Swiss Army knife metaphor, where the tools include renewable water reuse, biomass energy, water contaminant destruction, water sterilization, nutrient removal, phosphorus recovery, BioChar fertilizer, and carbon sequestration. NUTEC is our third-generation reactive filtration water treatment technology, and it uses a metal functionalized biochar as a sacrificial catalyst with ozone for catalytic oxidation in wastewaters. Reactive filtration uses a proprietary technology to make the sand surfaces in a moving bed sand filter highly reactive for removing trace contaminants. Well, new tech can take many dirty waters to a level of treatment required for unrestricted reuse and recycling. Catalytic oxidation allows for the destructive removal of most organic contaminants, often by mineralizing them to carbonates, and it sterilizes the water, which means it kills all microbial life, including prions, viruses, and bacterial spores. We know new tech can be scaled from gallons per minute to tens of millions of gallons per day, since it is built on our already commercialized reactive filtration platform that has a national and international installation record in demanding water treatment applications. It is a high-flow process that only takes a few minutes to remove water contaminants and pathogens. Agricultural, municipal, industrial wastewaters are good candidates for application of the technology. Third-party engineering studies conclude that reactive filtration is 1/3 to 1/2 the capital, maintenance, and operations cost of other approaches, such as membrane ultrafiltration. New tech can produce energy, a biochar fertilizer, carbon trading credits, and clean, reusable water. These byproducts create additional value for new tech. Well, there are 6 issued University of Idaho patents for reactive filtration. New tech is US and international patent pending. On the 1 to 6 technology development scale, new tech is graded at 1 to 2 early stage demonstration. We have licensed partners in the water treatment industry that have successful reactive filtration installation history and a distributor network across the United States and international. We expect commercialization in late 2016.